Okay, Math 9, here we go. So we have worked our way through what fractions are, what equivalence means, how to convert from mixed to improper, and here we are, we find ourselves finally starting to add and subtract fractions. So there's a few things we need in order to do this, but before we jump into add and subtract, we'll start with simplifying. Now simplifying we've kind of seen before, and simplifying a fraction is when we remove a common factor. So if you just think about the fact that 2 over 4 is equal to 1 over 2. I know when we did the equivalence, we were like, well, we could just divide by 2, divide by 2. That divide by 2 step is removing a common factor, because consider 2 over 4 is 1 times 2, and 4 would be 2 times 2. That's 2 over 4, right? But then you have a common factor, boom, boom, they cancel each other out. Because 2 divided by 2 is 1, and 1 times anything is anything. So when we cancel something out, it equals 1, but we don't keep it there anymore because it's a 1. It's redundant. We don't need it. So that's what we're going to do here. We're looking for common factors, and this helps with your factor tree again. Like, what's 28? Well, 28 is 4 times 7, and 4 is 2 times 2. So instead of writing 28, I'm going to write it as 2 times 2 times 7. 54, well, I know that that is 6 times 9, which is 2 times 3, 3 times 3. So now I have 2 times 3 times 3 times 3. And when you have everything broken down into factors and it's all multiplication, which this is, you can't cancel over addition, we can cancel a common factor. So in this case, a 2 cancels with a 2. Now that's all we can do, so we're left with 2 times 7, which is 14, and 3 times 3 times 3, 27. So that is the simplified form of 28 over 54. And it's simplified because we've already removed a common factor. This is going to become a consistent thread here is, are there any common factors top and bottom, numerator, denominator? Because then that's how we know we can simplify something. So now let's look again with 36. Well, you also can be strategic and you know, well, 36 is 6 times 6, and 60 is 6 times 10. So why would I continue to break down the 6? So we could say, okay, well, 6 times 6 and 6 times 10. Well, you could already see, boom, boom. Well, then let's just continue with the 6 over 10 then. Well, 6 is 2 times 3, and 10 is 2 times 5. So you can do it like this as well. It's just you identify the common factors, 2, 2, and you're left with 3 over 5. So that is the fully simplified form of 36 over 60. You could be even more strategic. You could go, okay, well, hold on. That's 3 times 12, and that's 5 times 12. If you're really good with your multiplication, you can get here, and then it's just like, okay, boom, boom, and again, you're done, 3 over 5. So this is, again, why multiplication basics division is so important, because we use it over and over again. And it's these concepts of canceling common factors, not just canceling the common factors, that is so important. We are going to cancel common factors in the years ahead, but the factors aren't just going to be simple numbers anymore. But the principle of canceling out common factors remains. So let's do a couple more. Well, again, strategic. Do you see the number 27, the number 81, and anything jump to mind? Well, 27 is 3 times 9, 81 is 9 times 9. Now you can already see a 9 is going to cancel, so let's just break down that other 9 on the bottom. So we have it like this. And you can do this because you're looking for common factors, right? So then it's like, okay, 9, 9, 3, 3. And here's a good moment because you can see there's nothing left on top, but it doesn't mean we have 0. Because remember, it's a 1, a 1, a 1, and a 1. We just don't write them anymore, but that means we have a 1 left on top. That's really, really important. It can't be a 0. I mean, that wouldn't make sense, because if you canceled this out to this and you said, oh, yeah, now it's just 0 over 3. Well, 0 over 3 is 0, and there's no possible way that 0 is equal to 27 over 81. So it can't be a 0. If there's nothing left in the numerator or the denominator, there is a 1 left. Okay? So then one more, 28 and 105. Well, 28 is 4 times 7, which is 2 times 2. 105 I can divide by 5, so it's 5. 21. 21 is 3 times 7. Again, I do this really quickly. I've been doing this a lot. So take your time on your factors, make sure you're getting them, but do the trees because it's super helpful to identify your factors. So here we have 2 times 2 times 7, and then 3 times 5 times 7. In this case, our 7's cancel, and we're left with 4 over 15. The good news about this is by breaking it down into primes or into factors, you can see right away that nothing else factors. So once you multiply things back together and you get your answer, like 4 over 15, you shouldn't have to think about whether or not it can cancel, because it definitely can't, because you've already canceled out all the factors you can. So that's simplification. So now let's dive into addition and subtraction, and we'll simplify at the end. Now, in order to add and subtract fractions, because you got to remember what fractions were, is they were wholes broken into different pieces. So all size 1, because all these fractions we're dealing with numbers between 0 and 1. So everything has a numerical size of 1, but we're breaking them down into different size pieces. If you're going to add and subtract these things, you need the same size pieces. I always like to think about, okay, Halloween Kit Kat bar, regular Kit Kat bar, Kit Kat Chunky. Sure, they're all Kit Kats, but you can't compare them all because they're different sizes. If you're going to compare them and count them up, you need to break them into the same size, which is what we need a common denominator for. Now, if you look at this first one, we already have a common denominator. That's great. If you have a common denominator, you have no hard work to do. All you do is either add or subtract the numerators. So in this case, we have 1 plus 3 all over 4, which is 4 over 4, which is 1. Now you do not add the denominators because the denominators are the size of the pieces, and that message continues through. It reads kind of like this. I have 1 of those, and I have 3 of those, so now I have 4 of those, which means I have 1. So the second one, I have a common denominator, so it's 2 plus 1 over 7, which is 3 over 7. So this stuff's really easy when you already have a common denominator. Again, I have 5 minus 1 over 3, which means I have 4 over 3. Improper fractions are fine. Don't bother converting to mixed. It's just more work than it has to be. So it's easy when you have a common denominator. What if you don't? Well, in this case, you just need to get one. And we get one using equivalence. So remember, we used equivalence in order to make a denominator a different denominator. So if I needed a denominator of 6, I would multiply by 2 and multiply by 2, and I would get 4 over 6. Equivalent fraction, same value as my original. So that's what I'm going to do here. I'm looking for a common denominator. Now, sometimes you'll need to multiply both denominators, sometimes you won't. In this case, can I multiply 2 by anything to get to 4? And I can't. I can multiply 2 by 2, so I multiply 1 by 2. So I use equivalence, which then gives me 1 over 4 plus 2 over 4. So now I have common denominator, and I just add them up. 3 over 4. Once you have a common denominator, things are awesome. Now for the second one, you can see there's nothing you can multiply 3 by, right? I can't multiply 3 by anything to get 7. So what I can do, guaranteed every time, is multiply 3 by 7 and multiply 7 by 3. That guarantees me a common denominator. So now I'll multiply by 3, multiply by 7. And now I have 6 over 21 plus 7 over 21, which gives me 13 over 21. And now we always check to see if we can simplify. And here's where I said factors come into play. If you look at the denominator here, the factors of 21 are 3 and 7. And the numerator 13 is prime. So they don't have any common factors, so you know no canceling, so no simplifying can be done. Same with 3 over 4, obviously. 3 is prime, 4 is 2 times 2, so we can't simplify that either. Last one. 3 times 8, 8 times 3 works. You'll see in a couple examples, we don't always have to just multiply them by each other, but here we do. So times 8, times 8, times 3, times 3. So now I have 16 over 24 minus 3 over 24, which gives me 13 over 24. Again, I don't mind seeing the number 13 because I know it's prime, so I just look at the bottom. Is that divisible by 13? 24 is not, so I know I'm simplified. So a lot of times people freak out when it comes to adding and subtracting fractions, but it's steps. Step 1, common denominator, yes or no. If not, use equivalence, right? Use equivalence. And then you have a common denominator. Then you're just adding and subtracting together numbers. So be confident and try. let's look at addition or subtraction, but we'll throw an integer fraction in there, so a negative fraction. Now in this case, this is one of the scenarios where my denominators are 9 and 6. If I multiply 6 by 9 and 9 by 6, I'll get a denominator of 54. Now, that doesn't mean I'm going to get the question wrong, but that denominator is way bigger than it needs to be, because is there a number that 9 and 6 can multiply into, a lowest common denominator? And yeah, it's 18. Now, if you don't know that and you go up to 54, again, it's not going to be wrong. You'll just have more canceling to do at the end. But it's good habit to get to a point where you can identify, okay, 9 times 2 is 18, 6 times 3 is 18. So I don't have to just multiply them by each other. So then multiply by 2, multiply by 3. Now, the negative in front of the fraction means the fraction is negative. And we're not adding or subtracting our denominator, so put it up with the numerator, just so you don't forget about it. So I have negative 4 over 18 plus 15 over 18. And remember our 1.1 integer work. Negative 4 plus 15, that's the same as saying 15 minus 4. So I have 11 over 18. Cannot simplify. Now I'll show you quickly, if you'd gone up to 54, you would have done 9 times 6, 2 times 6. You'd have had 12 over 54 negative plus 45 over 54, which would have given you 33 over 54. But in that case, they both have a factor of 3. And you end up with 11. See, if you get the lowest common denominator, the odds of you having to simplify decrease, which makes your life a lot easier. So now let's look at the 5 over 9. Again, common denominator that isn't multiplying them by each other. Well, 12 times 3 is 36. 9 times 4 is 36. There she is, right? So multiply by 3, multiply by 3, multiply by 4, multiply by 4. So I use my equivalence principle. So minus 20 over 36, minus 33 over 36. And you'll see it's a negative subtracting a positive. I'm getting more negative. You're adding the negatives together. So we end up with negative 53 over 36. 36 is only divisible by 2 and 3. 53 is not even and cannot be divisible by 3. So you are done. Again, don't bother converting into mixed. Improper's fine. So let's step it up one here. What about mixed fractions? So same thing, we just need to do all of our steps first. So first convert to improper. If you don't, the odds of you making mistakes increase exponentially. So let's go 9 times 3, 27, plus 2, 29. So I have 29 over 9. 6 plus 2, or 6 times 2 is 12, plus 1, so plus 13 over 6. We've seen these numbers before. They have a common denominator of 18. So times 2 times 2 times 3 times 3. Multiplication table might be handy in this. We'll talk about it in class. So 58 over 18 plus 26 over 18 gives us 84 over 18. Now, this is probably the first example we've got to where we picked the lowest common denominator, but we can still simplify. So 84 is 2 times 42, but 42 is 6 times 7, so we'll leave it there for a minute. 18 is 2 times 9. So looking at this, well, that'll cancel with that. But now I have 6 times 7 over 9, but 6 is 2 times 3. 9 is 3 times 3, so the 3's will cancel. So what am I left with? I'm left with 14 over 3. So you see we're tying everything together, converting, equivalence, adding and subtracting numbers, breaking into factors, canceling, simplifying. It's all there. So it's all coming around. And that's why this can get frustrating, because it takes everything we've learned up till now and kind of ties it all into one thing. And it's a lot of steps, but if you take them one step at a time, it's less daunting. So let's look at another one here. 3 times negative 3, well, not 3 times negative 3, sorry, 3 times 3 is 9, plus 1 is 10, but it's negative 10 over 3, and then minus 11 over 12. Now, this is a scenario where we don't need to multiply both because 3 times 4 is 12, so 10 times 4. So we have negative 40 over 12 minus 11 over 12. And again, we have a negative and we are subtracting, which means the same as adding another negative. So we're getting more negative, negative 51 over 12. And this is a moment where 12 is only divisible by 2 and 3 because it's divisible by 4 and 3, but 4 is 2 times 2. 51 is not even, but 5 plus 1 is 6, so I can divide 51 by 3. 51 divided by 3 is, it's actually the one number that I always think is prime, but then I realize it isn't. It's 17. So I have negative 3 times 17 over 3 times 4. 3's cancel, so negative 17 over 4. All right, let's do 2 more. Multiply this by this, plus this, so 7, 8, so negative 8 over 7, plus 5 times 14, which is 70, plus 3, so 73 over 14. Now again, this is a nice one because I only need to convert 7 times 2 times 2. So now I have negative 16 over 14 plus 73 over 14. And remember that negative, if you have one negative, one positive, you could rearrange. Negative 16 plus 73 is the same as saying 73 minus 16. It's easier to think of it as 73 minus 16. So 73 minus 16 is 57. So we get 57 over 14. 14 is divisible by 2 and 7. 57 is divisible by 3 because 5 plus 7 is 12. Go back to my divisibility rules video if you're not sure what I mean by that. So 57 divided by 3 is 19. So if you look at this as factors, we have 3 times 19 over 2 times 7. Nothing cancels. We can't cancel anything. So that is our simplified answer. Okay, here comes another one. So 5 times 5 is 25, plus 2, 27 over 5, plus 2 times 12, 24, plus 1, 25 over 12. Now this is a case where our common denominator is just going to be the two things multiplied together. So 5 times 12, 12 times 5, times 5, times 12. So here the numbers are going to get a bit big, but 27 times 12, we get 324 over 60, and 125 over 60. And when we add them together, we get 449 over 60. Now you might be thinking to yourself, well, I don't know if I can simplify 449, but since 60 is 6 times 10, it means 60 is divisible by 2, by 3, by 2, and by 5. So you can only simplify this if 449 is divisible by 2, 3, or 5. It's not even. 4 plus 4 is 8, plus 9 is 17. And it's not, doesn't end in 5 or 0. So we cannot simplify. So that is a quick way of me tying everything together with our divisibility rules. So lots of repetition here. Everything comes back. We got one more full-blown example where we have to deal with everything. So 9 times 3, 27, plus 2. So we have 29 over 9, plus 12 plus 1, 13 over 6, minus 2 over 3. Now, you might be at a point where, do I have to get a common denominator for all of them? And you do, but you could always do the first two and see if things cancel out, because it might save you some time. So let's just do the first two. 9 and 6, well, times 2, times 2, times 2, times 2. So now I have 58 over 18 plus 26 over 18, which gives me 84 over 18. Now, can I simplify 84 over 18? Sure I can, because 84 is 2 times 42. Well, 42 is 2 times 21, but 21 is 3 times 7, and 18 is 2 times 3 times 3. So I can cancel here, 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 and you can see I'm left with 14 over 3, and then minus 2 over 3. So not having gotten a common denominator with all of them keeps me from having to worry about that. And now 14 minus 2 is 12 over 3, and 12 divided by 3 is 4. Now, if you'd gotten a common denominator with all of them, you would have ended up here anyways, but you can see sometimes it's not necessary. Now, last one. 3 times 1 plus 2, so negative 5 over 2, plus 5 over 6, minus 9 over 4. Now what I'm going to do here is I'm just going to go ahead and get a common denominator right away for all of them, just to show you both ways here. Just draw a little line here to separate them. 2, 4, and 6, my common denominator is 12. So I'm going to multiply this by 6, by 6, by 2, by 2, by 3, by 3. The more you do this, the quicker you'll be able to identify common denominators, and it gets a little bit faster. So negative 30 over 12 plus 10 over 12 minus 27 over 12. So negative 30 plus 10 is negative 20 over 12. And then minus 27 over 12. Well, we are subtracting more, so we get minus 47 over 12. 47 is not divisible by 2 or 3, because that's all 12 is divisible by, so you have simplified. So you can see again, it comes back to factors, it comes back to multiplication of relatively small numbers, and then addition and subtraction of negative numbers. So I'm not trying to blow smoke when I tell you to really make sure you understand your factors and really understand your basic multiplication tables and really understand your simplifying common factors. So keep practicing, keep working, you're doing great.